1330 October 21st, 2024. Right now marks 256 hours of progress on the global horror simulation. As of this moment, a new script has been created for simulating a vision cone. Unlike previous scripts, which tried to create a vision cone in several different directions, this script only has code that allows it to generate a vision cone in one direction, going upwards. Likewise, unlike the previous scripts, this one does not actually, it's self-contained. It doesn't communicate with a script that tries to rotate the mouse and change the direction the vision cone is facing and update it. It's all self-contained and under 200 lines of code, which is a far cry from the previous updated script, which was the Vision Cells, which was around 500 lines of code, and that was stripped down from another previous script, which was the Grid Vision script, which was around 1200 lines of code, though around 700 lines of that were commented out just due to the complications of trying to create a vision cone in several different directions, and also trying to block cells and try to and all that in multiple different directions. And it was after a while of that, it was evident that the solution wasn't working. Well, the code that switches directions is working, but the actual code that needs to block individual cells on a vision cone was not working. So creating one wasn't the problem, and rotating it around wasn't the problem either. So this is an attempt to isolate the problem. So the intention for the next hour is to isolate the problem and just get blocking cells that shouldn't be seen by the vision cone working. And the idea here is to get it working in runtime. So each of these cells has a script attached called vision state, and the only variable on that is blocked. And so the idea is when this is toggled on, it will switch to blocked, and then the vision simulation script will notice that, toggle the object red, and then it will try to manipulate the objects behind it to also be blocked, and so on and so forth, in order to get this working accurately in as simple a way as possible, so that then once it's working, it can be ported over to the more complicated implementations that require the rotating of the vision cone.